So welcome to today's EOTEC DevNet webinar. My name is Martyna Slemaszczuk-Kulska, and I'm an EO expert at the University of Vienna in Germany and a member of EOTEC DevNet Secretariat. And together with my colleagues, Erin, Martin, and Jascha Moss, we will facilitate today's webinar. It's our pleasure to host this session where we explore the new Copernicus Data Space Ecosystem. This webinar is crafted to provide you with a hands-on experience, introduction, and also hands-on experience highlighting how Earth observation data can be leveraged for your projects and research with a special focus on capacity building. So during this session, you will gain an in-depth understanding of the new Copernicus Data Space Ecosystem and its capabilities, also including the newest one, learn effective approaches for accessing and utilizing Earth observation data, applicable in both your project and training endeavors, and discover innovative ways to integrate this data into your work. So with that, I'm thrilled to introduce Dr. Jan Musiał, who is Senior Data Scientist at CloudFerro and will be your guide today and will give the technical content, offering valuable insights and answering any questions you may have regarding the Copernicus Data Space Ecosystem. But before I will give the floor to Jan, I will give some introduction about EOTEC DevNet, which stands for Earth Observation Training, Education and Capacity Development Network. Okay, so let's start. For those who are new, Earth Observation Training, Education and Capacity Development Network, EOTEC DevNet, is a vibrant and growing global community of capacity builders and subject matter experts. The network was launched in March 2021, and since then we have more than 800 or around 800 participants from from 87 countries. And we are all connected with common goals, which are to improve collaboration among EO capacity building providers, foster exchange of capacity building resources, and reduce the application of efforts. Our founding partners are, as you can see on the slide, UNUSA, United Nations Office for Outer Space Affairs, VLAB, WMO, CEO's Committee of Earth Observation Satellites, and GEO Group on Earth Observations. Our thematic focus is disaster risk reduction, and also the second one is climate adaptation and mitigation. You can find more information about our network on our website. We will share the link in the chat. But to give you right now just a few more information how we operate. So we operate on global and regional scale. Global structures are composed mainly by our leadership and our founding members. We are focusing on sustainability and managing tasks, but also we have regional communities of practice, which are really a backbone of our network, that focusing really on exchange, on working on our products, like flat tools tracker that you can learn more on our website. And also we are happy to share the link right now in the chat about that. So this is really a heart of our activities, our regional committees of practice that I really invite you to join also to exchange with our participants and members. With that, I will give floor to Jan. So once again, thank you for taking this invitation to provide this webinar. So please, Jan, the floor is yours.
Okay, thank you very much. It's also a pleasure for me to be able to present you with the Copernicus Data Space Ecosystem. I hope you can see the presentation. So what is the Copernicus Data Space Ecosystem? Basically, it's the largest data space for the largest Earth observation program in the world. So basically, Copernicus Data Space Ecosystem replaced the Sentinel hubs from the 3rd of November and became the main distribution point of the Copernicus satellite data. But it's not only this, the data space offers way more tools for analytics that I will hopefully show you today. So what has changed since this 3rd of November? First of all, we have 57 petabytes of archival data that includes Sentinel, Landsat over Europe, SMOS, COPDEM, and now they are all immediately accessible. This means that they are online. There is no more need for ordering or restoring the offline products, which was very problematic before. All the data sets are unzipped. So you can now access only one band, for example. You don't have to download the whole products. And also, apart from the HTTP interface, we have now the S3 protocol. So there is more ways to access the data. We have new higher level APIs such as Sentinel Hub and OpenEO. And we have a software development tools in Jupyter that allows you to access the Earth observation data repository and to do the prototyping. And if you want to upscale your services to commercial level, we have also CRODIAS 2.0 platform. So our service team, it's composed of the main European players, let's say, in the EO domain. So we have a test systems, which is the lead of the consortium. I am from CloudFerro. We are the cloud providers. We have Synergize. We have Vito. We have German Aerospace Agency, DLR. We have ACRI and RIA. So regarding the data portfolio, we have Sentinel-1 with all the level 1 and level 2 products. We have also level 0 products, Sentinel-2, Sentinel-3, and Sentinel-5P. There will be also Sentinel-6 coming soon. Apart from the public Copernicus data, which were accessible before, we have other new products such as cloudless mosaics from Sentinel-2 and also the mosaic from Sentinel-1. We have Copernicus contributing missions, including the high resolution imagery taken over the regions where there was, for example, some kind of natural disasters. So this will be also available to users for free. We have digital elevation models. We have some data from Copernicus services, and we have Sentinel auxiliary and engineering data, which are provided to expert users in order to generate the higher level products. So we have also on-demand data access, and here I can refer to the Sentinel 1 level 0 product. We have also Sentinel-2 1B product. And we can also provide the commercial data to on the commercial terms to our clients. We have a dashboard which allows you to track how much data we have stored in the, for example, here last 24 hours, how many requests were done. So this just shows the scale of the Copernicus services. We have the very nice Copernicus browser, which allows you to search, query, and download products, but it allows also for interactive visualization and analysis of the most important data. You can also export subset of data. You can create 3D movies, for example, time lapses. I hope I will be able to show you this functionalities today a bit. So this is, for example, the search tab to query the data. So for the front end, this is the way that you will look through our archive. And this is how you can download the products. But there is also a visualization layer. So apart from true color composites, you can create false color composites of different kinds. So this is a huge step forward in comparison to what was before. So it allows you also to put more dates. So for example, here you can have kind of on-the-fly compositing. You can create also time-lapse movies based on your subset. So this allows you to look through the development of your phenomena in time. Here it's, for example, the phenomena of eutrophication of Lake Balaton. And this you can also see the dates, and you can create such a simple movie by yourself now with just a few clicks. So here there is an example of eruption, volcano eruption in Iceland. So here you can there are a lot of clouds here, but in the middle you can see some lava. That's if you turn to the thermal channels, you can see that this is still active. And with the feature of the 3D modeling, you can display how this lava was streaming on the terrain model. Here is also an example of the mud flood. So this was before. This kind of functionalities after and before for screen sliding. It's also possible. So this allows easily to compare between two dates, for example. So this is the NDVI composite. This is after the event. So you can see the huge damage that was done. And also there is a possibility to put your own code in order to create a kind of a classification based on this NDVI of the damaged area. Apart from the front end with visualization, we have a multitude of processing APIs, and here for data discovery and catalog, we have Stack catalog, we have OData and OpenSearch querying mechanism. We have S3 and OData for data download. For data access, we have for streamline access, sorry, we have Sentinel Hub and OpenEO. We have again Stack catalog, but we provide also OGC services such as WMS, which allows you to create a visualization and display then it, for example, in cookies. Maybe I will have a time today to show you this. And we have also the processing and statistical APIs to compute on a stack of image. On the multi-temporal stack, we have software development kits for Python and Java scripts, and we have clients for Java, Python, and R. So yes, so for the data access and processing, we have the OData, which is basically the REST-based querying system where you just have to create an URL in the browser or in the command line. You can post it, or there is another way to do it in OpenSearch, but basically as a response, you will get the all metadata required with dates, and this allows you also for advanced filtering of what you are looking for. So this is a powerful data discovery interface. We have an OpenEO API, which allows you to process the data in kind of an agnostic way. The OpenEO, it's a processing language where you have multiple clients talking to multiple backends, but in the same standardized way. And behind these backends are, of course, some kind of data cubes. So there is no need now to know the specifics of all the backends. You have one common, standardized, harmonized, you can say, data access API. And this is also connected to Jupyter and to data programming interfaces in Python, R, and Java. There is a cookies also plugin, and using this, you can create advanced EO processing workflows. For example, here on the right-hand side, you can see the crop classification done using OpenEO, and this is also provided below as an example, so you can check how it was done. We have, of course, Sentinel Hub with stack catalog, which returns the list of data sets. So there is yet another way of data discovering service. We have visualization for OGC services. We have process and statistical APIs, and Sentinel Hub also allows you to bring your own data in a cloud optimized GeoTIFF or in the ZAR format. So then you can use those advanced processing tools on your own data. So this is an example for large data processing. There is a batch processing algorithm which allows you to run kind of important or heavily computational over the entire Europe, as it is shown on the right. So the process are not, so the results are not immediately available. They are available after some time. You have the statistical API. For example, here there is an example of a function which computes some statistics over the agricultural fields for the common agriculture policy, for example. And there is also a nice QGIS plugin that allows you to visualize the data in the QGIS and to do some GIS processing based on this. We have a very new, I think, very interesting traceability service. And the purpose of the traceability service is to verify the origin of the data sets to prevent the manipulation. So basically now we know that within the AI era, it is easy to manipulate the data. And so to ensure that our data are original, there is a traceability service where you can put the name of the file or the checksum to see where it was generated, using which input data, and to verify if the copy that you have on your computer is the same or not. We will have also on-demand processing, which allows you to generate higher level products from Sentinel-1, such as backscatter or coherence. And from the Sentinel-2, we will have also additional ways of doing the correction, atmospheric correction, for example, to generate level 2A products using Maya or Force. We will also have the Sentinel-2 resolution enhancer processor. What is also worth mentioning that these are our tools, but the ecosystem is open for others to join. So it's not only done by our companies. There is a marketplace where you can put your algorithms, for example, for CAP monitoring, image analysis, or machine learning. And the common thing is that all of those services are based on the Copernicus data. We also provide wide user support. We have a service desk with web form and email support. We have a documentation portal with some YouTube movies with frequently asked questions. We have also user forums, so there is a lot of ways to interact with us and to find a solution for your problem. And here it's also worth mentioning that there is a difference between the Copernicus data space, which is provided to you, to general users, completely for free for prototyping and for data discovery. But in a way, if you would like to have your service commercialized and operational at the large scale with large scale processing, then you would have to move to the third parties services. And one of those services now is the CloudIA's platform that I will mention in a while. We offer also the onboarding and federation of third-party services, as I have already mentioned. And the quotas available are also listed here under this web page. So we have 4 types of users within the data space. We have Copernicus general users, which I guess most of you fell into this category. But we have also Copernicus service users. For Copernicus services, we have Copernicus collaborative grant segment and Copernicus international partners. So then if you fall into these other 3 categories, then you have larger quotas for the free services, and then you should apply via the form or contact the European Space Agency to get the higher level user of user. So as I mentioned, the first commercial element of the Copernicus data space is CloudIA's platform, which basically is a gateway to all of the services that I was showing you before with all the APIs. But here there is a way to apply for additional funding, for example, or also there is a way to access the infrastructure as a service, so the cloud computing capabilities. So this has to be said that within the Copernicus Data Space Ecosystem, there is no as such cloud computing capabilities provided. You have some notebooks and some APIs that of course are run in the cloud, but there is no way to order virtual machines. And for this, it's good to go to the CloudIA's platform, which provides you with the additional computational resources, VMs, object storage. We have also software enabled images with OSGeo cookies and, for example, Send4Cap pre-installed. We have managed Kubernetes, and it's done on 2 clouds. One is our cloud, and the second one is the Open Telecom cloud. So I will just tell a few words about our clouds. They are located in Warsaw and in the Frankfurt. So there is a wide range of services available with different VMs, different dedicated servers with GPUs, environmentals, Kubernetes, with load balancers. So as it was said, if you are developing something in the Copernicus data space ecosystem and you are happy with it and you want to scale it to the next level, or you have a large research project where you want to let's say process the entire Earth or the entire Europe, then you should apply for financing on CloudIA's. So our cloud is also based on completely on open source, so we run OpenStack, and we have very flexible billing, per use, pay as you go, and fixed term. And we have special discounts for contracts longer than 1 year, and we have also special discounts for scientific institutions. And furthermore, we offer 250 euro free credits if you would like to try the platform by itself. And the second cloud, it's the Open Telecom Cloud, which, as you can see, there is also multitude of different high-level APIs that may be needed by your service. It's also based now in 3 regions, and there is also very nice price calculator when you can estimate how much resources, how much they will cost if you order one. So this was for the Copernicus Data Space Ecosystem. So just to sum up, the new Copernicus Data Space Ecosystem brings full archive of Sentinel satellite data immediately available. There are new data searching, access, and processing APIs. We have a nice browser, which I will show you in a minute, with the visualizations and 3D capabilities. And also the Copernicus Data Space Ecosystem is set for 6 to 10 years. So this is a long-term project. So there is a possibility to have a long and fruitful collaboration with us. Okay, so if I will finish this one, I will try to.
There is one question, Jan. Maybe you can just straightforward because it's related to the presentation. The question is, what about historic ESA-SAR data such as ERS and NVSat? Will they be available in the ecosystem?
Okay, so for the historical data, they are not yet planned to be added, although it all depends on the European Space Agency. If there is such a request, we can. There is no problem of adding those data sets to the ecosystem. And I would suggest if you have such a request, then please use our contact form or frequently asked questions, and then just write a question, and then it will be visible to everyone that such data are interesting to users, and then they should be added. Okay. So I hope this answers your questions, and I will try to show you now a bit of hands-on, as Martyna said. So if you log to the data space Copernicus EU, once you register, you can log in, and I will walk you through the available services. So first of all, for the data exploration, we have a Copernicus browser, which looks like this. And you can hear them here. You have a message that you have to zoom to some certain level in order to be searchable. So now we will search, let's say, all the data over Warsaw. So we move to the search criteria. So let's say we want to look for Sentinel-2 level 2A data, and here we can also adjust cloudiness. So they are cloud free. So or with small cloudiness, let's say. So I don't know if maybe we will make it not October, but September. September, there was some nice weather in Poland. So now you can see we have already some matches. And so here they are a list of products that fulfill the criteria. So if we go here, we have information about the product, metadata of the product. So all the information is here, and you can start here the download. So it will start the download. So at some point, once it goes to 100, it will be possible to be downloaded. And also here you can also click download, and it will also start to be downloaded. But maybe the more interesting feature is the visualization of the product. So here we have visualization, as you can see, not only of one single tile, but for the whole swath of Sentinel-2. If you zoom out too much, then there is too many data to be fetched, and there will be this yellow warning. So you have to be at a certain level to be able to visualize the data. So here we have Warsaw, and this is a true color composite. But as you can see, we can create a false color here to see more the vegetation layer. We can visualize the NDVI index. And here, for example, what you can do, you can straight away create a histogram just to see over the entire here area of interest, what is the frequency of the values of the NDVI index. And if we zoom in somewhere, we can select also an agricultural field using the polygon, draw the polygon feature. So let's say, okay, this is our agricultural field that we would like to analyze. You can see already the area calculated, and we can use the statistical info. So this gives you the whole NDVI curve starting from 31 August. So this is 1 month. You have you can have, let's say, 1 year of data, and you can see that it's calculated on the fly, 1 year NDVI data. And of course, what you can see here, there are those spikes based on the cloudiness. So what you can do, you can switch it here to remove the cloudy points. So now we will have only the scenes that are less than 20%, and we can see some development of the NDVI index for this particular agricultural field. There is also a spectral explorer, which is also a pretty nice thing that shows you how the different bands look like. For the sake of the record, you can overlay some theoretical spectral curve for grass, or for water, or for soil, for example. So as you can see, for the time being, our field looks like a bare soil. It matches this spectral curve very well. So this is for this kind of an analytics. You can also create draw a line to have it. Maybe I will do it across the Vistula River, somewhere in Warsaw. So if you draw a line here, you will be able to visualize the terrain profile, so how the elevation looks like. So here you can see that we have Vistula River somewhere here. And yes, here, as the people who know Warsaw, they know that here there is our old town. It's way higher than the river. So this can be done very easily using the browser. What's more, you can download the image that we are displaying now. So you can download the image as it is, but you can also download it in an analytical so-called form. So then we would probably want to get the NDVI in 16 bits. You can also, instead of the NDVI, you can request other additional bands. And then with just quickly one download image, and it will process in the backend, and it will create the zip files with all the bands that you have requested over this AOI. So this is also very nice way of accessing the raw data. Okay, so there is another cool feature. I don't know if this will work here, but let's say over Warsaw, you can generate a movie to see how NDVI was evolving. So here again, we would decrease the amount of clouds. And maybe we will also extend the date. So let's say from March, maybe from April. I don't know if it will not take too long, but if we go search, so it now checks all the Sentinel-2 scenes that were crossing this area of interest. So this will take a while, because as you can see, there is already a lot of them. Okay, and I think it's 21 of them. And I think now we can start kind of an animation that shows you how it was evolving during the year. You can see still that some clouds are not masked, because this is just overall cloudiness over the whole scene, not over the AOI. And in this way, you can create the visualization. I think you can also check if we move, you can use different visualization, moisture index, for example, or difference water index, normalized difference water index, for displaying this functionalities. Okay, and now I will just show the, or maybe I will just reset the browser, and we will go somewhere where there is a nice elevation, so probably somewhere close in Alpine regions. So here we have a lot of elevation. Again, we will do the data search. Okay, there is a okay, it's already covered in snow, as you can see. So now I would like to show you this 3D capabilities of the browser. So here, as you zoom in, you can zoom in here, and you can see this is the true Sentinel-2 image dropped over the elevation model. So this allows you also to better understand the phenomena that you are looking at very rough topography. So you can see all the valleys, and where, for example, the snow is covering the higher parts of the mountains, whereas the valleys are still not covered by fully by snow. So we can go back to the 2D mode. So this was very quick presentation of the Copernicus Data Space browser, but there is, as I said, way more tools available in the Copernicus. So we have this traceability service.
Jan, if I may, there is one question about visualization, then maybe I can ask directly.
Yes.
Will the visualization, be adaptable, like color map and also the value range?
Okay, yes, so I forgot maybe to mention that here there is also a way to create your own composite with all with your own levels. So you can create kind of an index, simple ratio index, and you can also set the thresholds here. So in this sense, it's very powerful. And if this mode is not yet you need more than this functionalities, you can also create a custom script here for the visualization of the layer. So in this sense, it's very flexible and it allows you to select bands and to clip them as you want.
Thank you.
Okay, so I will try this traceability service. So in the traceability, let's say we go back to search. We look for this particular scene. So if you put it here, you can see that there are two traces of this product. One was the create trace, so it was created and then moved to another one. So it's not only the thing where it was created, but it's also when it's available. So if there is more services with exactly the same product, you will see more copy traces. But if we are going here into this in this overview of this product, you can see the size, you can see the checksum, and this allows you to verify if this zip file is original or not. But also you can go into the content of the image, so you can see the checksum of each file within the product. So for example, here, each checksum for each band. So you can use the traceability service in another way. If I go duplicate tab, and if I go search, you can check the checksum. So you can see that it was already, I put the checksum of the image that you have on your computer. You can see what was the, this is for a single band, and you can see the product that holds this checksums. So this is a really powerful tool to, first of all, verify if your data are original, and another thing, it's what was the input data to this to generate this product. So this allows you to track also how it was done. So this is the traceability service. If I go further, we have the Jupyter notebook, which I think it's pretty cool functionality. If we go here, you can request 3 types of servers: small servers with 2 CPUs and 4 GB RAM, medium servers with 2 CPUs and 8 GB RAM, and a large server with 4 CPUs and 16 GB RAM. And basically this allows you to analyze even the large satellite scenes, but maybe you will go for a medium server. And the server is being requested, so this will take some time, but off we go. You can see already that it has started. So what you can see here, this is this Jupyter notebook environment, and here you have your personal space when you can put your files, not only the notebooks themselves, but also the data files that you want to analyze, and you have also samples. So here there are easy examples of the Jupyter notebooks. Here, for example, it's the example how you would like to, if you would like to search for data, how you should do this with the OData query. So you can display here, you can download the bands and visualize them also in the notebook. And this is done using the normal kernel. You can have different kernels here. You can have an OpenEO kernel with OpenEO library installed. You can have a generic Python 3 kernel. So if I go here, for example, and maybe I will go to code. So then you can go one by one, and you can prototype your algorithm using the, oh, I think, okay, yeah, we have not imported the correct kernel, so it has to go here, because this kernel has all this libraries pre-installed. Right now it's okay. So this is how you can prototype with the Jupyter notebook. Also, if you would like to have, maybe I will go here, you can upload also a file. So this is what I saying, but if you would like to have just so I will close this one, discard. You can create and open here a notebook. So here you can also import some libraries. So for example, I don't know if you would like to import the library that does not, I think this one is not installed. It will tell you that it's missing. So then you can also add additional libraries by just doing the simple pip install bottleneck. And if you execute this one, it will download the library, install it. So then if you go back, you can see that it's already installed. So this allows you to use not only the libraries that are pre-installed, but you can also add additional libraries to your notebooks. So here I will say a few more words also about other APIs that are available, especially the OpenEO, which is kind of data processing engine similar to Google Earth Engine, but it's completely open source, and it's here available also for free. So for the sake of the presentation, maybe I will show the NDVI time series example, which is already here. I think so for this, I will also not run the entire notebook, which is also nicely described here because it takes too much time. I will just focus here at the beginning of the script, because here you import the libraries, then you need also to authenticate, and for this there is a URL that is generated. Then you confirm that this is you, and you can see that it's successful. Then you can here you have some agricultural fields in GeoJSON. Then we we are loading the Sentinel-2 level 2A data cube. And here we are selecting bands to compute NDVI. And here there is a time series generation, a step. And this is also a nice step which executes this function on a larger set of agricultural fields and time. So this takes some time. You can see that the jobs are starting. There will be several of them. And this brings me to the other functionalities that are available here. So we will go directly to the OpenEO backend. I hope I will not kill my web browser. Maybe there's some time needed. Mute up. So okay, and if we run OpenEO, it connects to a server. And here there is also a nice feature of OpenEO Web Editor that you don't have to know how to code, write functions in Python or in Java or in R. You have also a graphical interface, kind of a block builder for this. And here in the runtimes, I think, yeah, so these are the libraries that are available. And here, sorry, I somewhere on the this requires, okay. So if we log in, okay, with the Copernicus Data Space Ecosystem, you can see our batch job that was initiated in the Jupyter notebook. And here you can see also graphically what was done with the data. There was a reduced dimension step. There was an aggregate step to get the data for each agricultural field, and that data will be saved. So I will not tell more about OpenEO. There is a lot of very interesting tutorials and materials that you can learn how to use it. But okay, here we can see that it was already done. But it's very powerful tool and it's completely for free. And as compared to Google Earth Engine, it also allows you to run your own instance of OpenEO. So if you have your infrastructure or our cloud infrastructure, you can deploy it on wherever you want, on whatever cloud. Okay, and last but not least, I will just want to show you the dashboard of the Sentinel Hub. So here you have the statistics. The main bar dashboard shows you how many processing units you have, how many requests you have done, and what type of user you are. And in the configuration utility, you can create a new configuration. Let's name it EOTEC DevNet. Create select from instance. Okay, for example, if you would like to have the WMS service, and here you have all the different channels or different channels combinations that were also visible in the browser, and also way more. So if we go to the back, all these visualizations plus the raw channels should be visible here at the in the dashboard. And what is very nice, you can also set the image quality. Maybe you would like not to have the logo shown or your WMS. And here you can get the WMS or WMTS path. And then this you can put in the QGIS, for example. So here we have QGIS. So we go out here, we go WMS, WMST. We can create a new net. We paste this URL. We go OK. We go connect. Then, oh, sorry. I have a lot of WMS specified here. So this is the one that we have. And we have different layers here that are available. So if we want to go to true color and then let's say in JPEG, okay, we can set the time, but it's okay like this, just to show you. And as you can see, it's written that you have a zoom level which is too big. I will just put some data. I think here the projection is somewhere different than I would expect it. Maybe there is a chance to change the projection to maybe something which is more needed. Okay, so we go again to Warsaw. And here hopefully the images should load. And if not, then we would need to change the projection of the layer here. So for this, maybe we will just reload once again the layer. So for this, if we go, I think there is no way of also we can also do it a bit differently. So instead of WMS, WMTS, we will do the WMS path. So then it will be a bit easier. Layers, edit. So if we just paste here the path, I connect. Okay, so this will work easier than the WMS, the WMTS, and here if we go RGB true color. Okay, and here again we add some map. Okay, and now you can see the composite which is displayed in your cookies. You can see a lot of clouds as well, but this can be again adjusted here. So if we go to true color, and if we, sorry, I think, Yeah, you can adjust how much the cloud coverage should be. And you can set the way that the mosaic is done, so from the most recent or from the least cloud coverage. So if we do like this, layer successful, then this should, maybe there is not more cloud-free scenes here, but this has also an impact on the WMS that are displayed here. So they are quite custom. You can customize them a lot in this respect. Okay. So this is for the OGC services. And I think our time is more or less running over. So if there are some questions, I will be happy to answer them.
Are there any questions? Please feel free to turn on your camera and microphone and ask directly.
So I would have a question if maybe you mentioned it, but or I missed it. Will there also be a possibility for interferometric processing?
Or no, I have not mentioned it. I think some OpenEO functionalities can be done, have some interferometric capabilities, but if not, you can also in the Jupyter notebook install some custom libraries that are for interferometric processing.
Okay, thank you.
Maybe to wrap up your presentation, I would have I have one question about the future and maybe some other future developments. Are there already in plan any new additions or any improvements?
So yeah, so it has to be said that the Copernicus Data Space, as you can see, was developed in 9 months, more or less. So we are still in the development phase. We have a lot of functionalities, as you could see, already running, but there will be more of them. First of all, we will have more data. For example, these Copernicus contributing missions are coming soon, maybe beginning of next year. For the Sentinel-1, we will have also the possibility to select not the entire image, but specific bursts. We are working for the improvement also of our stack catalog to add assets and to add custom additional features to stack, custom extensions. And this is not the end, because the ecosystem evolves all the time. So there are new requirements which comes from ESA, but also there are some new functionalities that are provided by third parties, and they are added to the ecosystem. So we will see in the future what will come.
Is there a newsletter that one can subscribe to get news and developments?
For sure, there is a news on the web page, but I am not here. There is a documentation for portal. There is a frequently asked. You have a user support and you have a community forum. So here, if you put your question, or maybe you would like to ask a question, then it's good to see here if it was answered. But for the latest news, I think there is just this tab for the time being.
Okay, great. Are there any questions? Any further questions to Jan? There is one question about from Claudia. Would you like Claudia to ask directly?
Yeah, can you hear me?
Yes.
Great. Yeah, basically you just asked the same thing. I wanted to know about the future plans for the browser part, for example, Sentinel-3 land surface temperature or something, level 2 data. And for now in the workspace, there are only like 5 processors. What other stuff is planned? I'd like to know that too.
Okay, so for the additional visualization, we will have all the high resolution data from Copernicus contribution mission added. There are some functionalities which are added, but not for the general users, but for expert users. And in terms of the Sentinel-3, I think there's some developments also planned for this. You mean for the land surface temperature? So we can.
Yes, you can download it, but you can't really just look at it so far.
Okay, so I think there is some visualization as well planned, but the thing is that in order to be able to visualize a product, it has to be in some kind of a cloud optimized format. And for the time being, only Sentinel-2 and Sentinel-1 data are saved in such a format. I think Synergize is also converting some of Sentinel-5 data to COG, but basically this is still on the way. So our plan is to have everything visual that allows for visualization, but this is still ongoing effort. Yes.
Okay, thanks.
As you can see, they are in the I think they are in the NetCDFs. So they are the NetCDFs that does not have overviews. They have just quick looks, as you can see here. So this is still to be done.
Okay, great. So thank you very much. If there are no further questions, I would say thank you very much, Jan, for your presentation. Thank you for the hands-on and all the information provided. As you mentioned, there is a support, there is Q&A and some tutorials available. If you want to get more information, it's available. There are still developments ongoing, so you have to stay tuned to get the latest informations. So thank you very much all for joining. Before we close the session, I would like to just invite you to our EOTEC DevNet on upcoming events. So I hope you can see my slide. So as my colleague Erin just shared in the chat, we invite you to join our communities of practice and be part of our growing network of capacity builders. So please join our quarterly regional COP meetings. The next one will be in December, on December 6th and 7th. So on 6th for 2 regions, Americas and Africa, and 7th, Europe and Asia, Oceania. And in January, we will have our FLATS working group meetings. Through our communities of practice, you can contribute to our capacity building products, contribute, for example, to EO needs assessment matrix and other products. You can engage with global peers and share your research and exchange information using our online member platform. So please go to our website, dive into the information that are available and join our community. And with that, I would like to thank you once again for joining our webinar. So thank you for joining, and hope to see you on our meetings, regular meetings, and also other webinars that we are planning to have next year. So thank you very much and have a great day, and see you online. Thank you. Bye.